Hello and welcome to part 2 of our tutorial video series. In this tutorial we will start where we left off in our part 1. We created the effect where we had a fluid simulation inside a container, a sphere object, and we are now going in this video to use this simulation to drive real particles in 3D Studio Max. Just as a little reminder, here's the container object, the sphere we created, and that's how the effect looked like. So we have this gas and fire smoke contained inside of this sphere. So we will now use this simulation to drive particles inside of 3D Studio Max. We will use thinking particles to create these particles, and in this video we will do that from scratch so you can follow along and learn how to do this effect. The first thing we need to do is export the needed data, and that means we are exporting a VDB file including the density, temperature and velocity. We need the temperature for rendering. We're not going to render or discuss rendering here, so we would just press the export button and it will start exporting the VDB files. We have 500 frames, so it is exporting now 500 frames, and it will include the density, temperature and velocity. Also make sure you have Y is up and world space turned on, so that when Thinking Particles loads it in, it's already in place and you don't have to readjust anything at all in your scene. Use VDBs for rendering is useful when we want to render the effect later on. So now we have 500 files, individual VDB files, all with velocity, grids and everything in there. Let's create a particle system. So we're going to 3D Studio Max create objects, particles, system, and we're creating a thinking particles. We pop the helper anywhere in our scene, it doesn't matter. And I'll bring up the properties of thinking particles. First thing we want to do is create some particle groups where we want to store our particles we will create in this tutorial. And I will have a particle group and a VDB group where I store the VDB particle that holds our VDB data. Then I'll create 3 dynamic sets. The first one I'll name create. This dynamic set will create the particles. Then we have another dynamic set where we will do the simulation stuff. And the last one for cleanup. Usually I like to have one last dynamic set for cleanup to delete particles or do any kind of cleanup in the scene. The next thing we need to make sure is our particles, they should carry the density. I want to do some effects based on density in our smoke simulation. So for example, the density should drive the scale or size of our particles. So let's create the particles right at the center of our domain or where the emitter is. And for that we will do several things. First, we are going to create a position born. So we are using the position born. I'll press the tab key, type in POS, and we get our position born node. And for that node we need to supply the position, and I'm doing that with a node helper. Again, I press the tab key, type in node, and we get the node helper. The node helper lets me pick any object in 3D Studio Max, and let me just pick our geosphere object. That's our collider, and our collider can be used as a node to supply the position because the collider is in the center as well, the pivot point. So very easy, we have the position now. Particles are created right at the center. The next thing is let's create a constant stream of particles. Let's say 1,000 particles per second. Also we need to make sure the lifespan is set accordingly. We have 500 frames. And we don't want to have any speed because the particles should flow along with our fire simulation or fluid simulation. And I want to create a kind of a volume inside when we create the particles. So we have in all directions particles that can move in every way. And I'll make sure we increase the emit distance and the variation. So that will give us a sphere filled with particles. The radius is right now 5 centimeters. So now we have particles created in the center, in a volume. And the next thing I'm going to do is standard shape. We want to make the particles little spheres. I'll select the spheres. And there we go. That's all we need. We create the particles. We got the position from our collider in the center. And that's it. There we are. We create these particles with a radius of 5 in the center. And we create 1,000 particles per second. So that was easy, wasn't it? Let's go to the next step. And we want to make sure that these particles follow our fluid simulations. I want the particles to move in the way where the smoke moves with the speed of the smoke. So let's do that in our next dynamic set. In the simulation dynamic set, I'm going to create a VDB file first, or a VDB container to be more precise. The VDB container is kind of a holder for all the data that we are going to import. So for that, we are adding the OpenVDB. And in the OpenVDB, I'm adding a fog and a velocity grid. That's the two grids we are interested in and we need for our effects. The velocity grid will tell us how fast and where the particles should go, and the fog field will give us the density at a position of a voxel. So those two grids are empty right now, so they are empty containers, and we are going to load them now with data. And I'm using the load VDB for that. In the load VDB, we just pick our container object, the OpenVDB there, and we need to specify our particle that holds all this information. And talking about particle assignment, we need to make sure we born the position, the particles in the particle group. So that's why I selected the particle group, and then the load VDB needs to go into the VDB particle group. So then everything is clean and sorted. So we want to make sure the VDB group is selected, and now when we load in the VDB file, it creates automatically for us a particle. And all these 500 files will be loaded there. The next thing we need to decide is how do we assign the grids that come in from the VDB. Usually you can name your grids as you want, so it's not clear what is what. So we need to make sure that we grab the density and assign the density grid to our fog. So this is an important step. We could assign it to velocity and any other aspect of our scene. However, we don't need that right now. We just need to make sure we assign the density grid to the fog OpenVDB container. So now the density information is loaded into the fog. Just keep that in mind. VDB files are no standard in that sense that you can name whatever you want your grid. So it's not clear, is density really a fog or not? So we just assigned that and told thinking particles what it is. Now we could already start visualizing our VDB file, and I'm going to do that right now. We just need to select our container where the data is and what we want to visualize. So let's visualize the fog. And we have bounding box turned on, and we already should see when I reset the simulation, the bounding box is growing. We see the bounding box. So something is happening. The VDBs are loaded in and we can see it's expanding. We can visualize the individual voxels in there, and they actually look exactly like our simulation. But for now, let's just keep the bounding box, and we could go even a step further. We can actually look at the volume data in 3D Studio Max, and we need 3D Studio Max 2023 for that. But if we turn on volume display, we would see our actual volume in the 3D Studio Max viewport. So that's a much better display. However, it takes a little bit of time to load in each individual VDB file, and it's pretty big. But that's another important step to visualize where things are happening. Sometimes VDB files have a strange orientation, so we can check everything is according to the alignment we want to see. Okay, now that we have done that, we have created the particles, we have created the velocity, or imported the velocity data into individual grids. So all we need to do now is affect our particles we just created with our position born. The particles should move along with the velocity, and we also want to control the particle size and maybe a little bit of more fancy features like stretching when particles move fast and so on. So I'll get the grids now. So we're accessing the individual VDB grids. So I'll use a get grid node for that. And it gives me the individual grids in our OpenVDB file we imported, the fog and velocity grid. And the next thing is we're using an output to VDB. And that will allow us to pick any grid we want to work on. So let's say, for example, let's start with the velocity grid maybe. So we connect the velocity grid, and now we can assign what we want to do with the data inside of the velocity grid. So what we want to make sure is we affect our particles. All particles in the particle group will be affected now by this node, and we want to output the velocity. So what we're doing is we are overwriting the velocity of each individual particle with the data from the velocity grid. So there's interpolation options. There's a lot of options we can do there. But for now, for the sake of this tutorial, we just keep it at the defaults. So what we are doing here is taking the velocity out of the grid and assigning it to each individual particle. So this will make our particle move. I'm shift copying the output to VDB and using the fog grid, that's our density as well. And what I want to do is I'll transfer the fog, the density information to our data channel we created when we created the particle group. I'll store that in the density data channel. So now our particles carry the density at each position they move around. So now we have density, we have the velocity for each point in space and particle in space. So the next thing we want to do is control maybe the scale of our particles. So what I'm doing here is for each grid we're going through, I'll have to operate on the particles individually. So whenever the fog is called, it will activate my particle group and we go through all the particles for the fog data. When the velocity is called, we go through the group for all particles in the group for the velocity data. So now we can work or individually decide what we want to do with each individual particle. So now every particle is put out, is accessible, and we have the density data channel, and also we want to activate our velocity so that we can access the particle velocity. So now we have everything we need, and we can work on changing things in the particle based on velocity or the density of our smoke simulation. So first thing I'll do is I'll create a threshold based on the density. Because what I want to achieve is I want to delete particles when there's no smoke. Because the particles live forever in theory, I want the particles to die with the smoke. So when the smoke gets cooler and fades out, I want the particles to die. So I'll do that by having the threshold. Whenever a threshold is reached, so the density is very, very low, so invisible in our case, I'll just kill the particles with the particle dye. So this little setup ensures whenever the density of our smoke is close to invisible, so it's gone, we kill the particle. So the particles will fade out exactly with our fluid simulation. Then we might want to go and use the density for some other little things we want to adjust, the scale. So the more density I have, I want to have a bigger particle. The less density, I want a smaller particle. So the fading out of the particle will happen as the smoke fades out in size as well. So I want to shrink the particle based on the density of the particle. And also, I want to use the velocity to stretch the particles. The faster the smoke goes, the longer the particle or elongated the particle should be. So I could now use the density output as a scale factor, but we never know what density values are in the VDB file. So I'm using a value to value to make sure that we get the exact output we want and understand. So the value to value has arbitrary inputs. So our min and max values are arbitrary inputs. For density, it's pretty simple. Usually density 1 means it's maximum density opaque. Density 0 means it's fully transparent. So let me just add a little key here and do a curve so that we have a little curve for the fading out effect. So what we have now is we scale the particles based on our density between 0 and 3 size. So our biggest particles we have, or largest particles we have, is 3. And smallest one obviously is 0. So, and the input is 0 density or maximum density. So that is done now. Now I'll create another value to value and grab the velocity of the particle. So based on the velocity of the particle, we want to stretch the particle in z. So for the particle or for the velocity we get, I just looked at with a debug at the amounts of the particle. So we will adjust the min and max values accordingly to the speed values inside of the VDB file. And the maximum speed is 100. And I want to output a stretching between 1 being the original round particle and 7 a stretch particle or elongated particle. The only thing left now is we have everything controlled with particle information right now. So we scale along, we take the velocity from the field, and we take the density from the field to fade our particle size as well. The only thing left is we need to rotate or adjust our particle always along the z scale or z axis. So the particle should be aligned along z. And we can achieve this really easy in thinking particles. We are going to use an alignment. I'll grab the particle up here, feed in the particle, and then we just want to make sure we align along z-axis based on the direction of travel. So wherever our velocity sends our particle, we stretch along the path. So that's it. Really easy, simple setup. We have now everything we need to get our particles moving, to get our particles scaled and scratched and fading based on our VDB data. So let's have a look how this actually works and turns out. Let me just reset the simulation here and just play this simulation in real time in here. And we already can see that our particles are scaling and stretching. Let's just zoom in a little bit more. So we see as they move around, the particles stretch. The faster they are, more elongated, and the slower they get, the rounder they are or smaller they are. There's one thing left we need to consider, and that is when the particles reach our collider, the velocities will disappear or go down to zero, so we will accumulate particles at these positions. And I don't want that. So this is why we need to clean up the zero positions or zero velocity positions of our particles. And let's just make sure we kill the particles when they are hitting the collider. And we can do that really easy in thinking particles by just grabbing our particles, and we test all of our particles if they collide actually with the object. I'm using a universal deflector, and the node helper again, we just pick, like we did before, we pick the geosphere and we'll feed in the node to the universal deflector. So now particles will collide. And we just need the event. We just want to know if a collision happens. We use a particle size for collision. And that should allow us now, based on an output, to kill the particles that are actually colliding with our container. So I will kill the particle whenever collision happens. Let me just feed in the on. And now we have the setup. Particles hitting the collider will be killed right away, and usually that will prevent an accumulation of too many particles at the same spot. We don't want that, and let's see if that works. So when we go back, reset our simulation, and we'll play back our simulation. Let me adjust to sprites, which draw a little bit faster in the viewport, and we can see as soon as they hit the actual collider, we kill the particles. So we don't have anymore the issue that more and more particles will just accumulate in the same region or same area. I hope you enjoyed this video, and please check out our other tutorial videos as well, and thank you so much for watching.